The arc wasn't near the poles. It was hanging over a place that normally never gets that kind of sky. People called it a camera trick, a filter, a viral hoax. Then the next night, a different arc lit up on the other side of the planet. Same shape, same clean edge. And the weirdest part wasn't the color, it was the timing. The glow held like it was locked to a stopwatch, then shut off with the kind of sharpness nature rarely uses. If you've ever watched a real geomagnetic storm, you know it's messy. It swells, fades, surges, stutters. This didn't stutter. It behaved like a scheduled window. While everyone argued online, the quiet feeds were already screaming. Magnetometers that barely twitch on calm nights spiked in a thin band, like someone dragged a line across Earth. At first the line made no sense, because it wasn't following latitude the way auroras should. It was cutting across regions like a path, not a cap, like a corridor. Now here's where 3i Atlas enters the frame, not as a headline, but as a metronome. Every time the object hit its pulse window, the reverse aurora showed up too. Not always over the same city, not always even on the same continent, but always inside the same time slot, like the sky was responding to a trigger you couldn't see. Let me keep this simple. Auroras happen when charged particles ride Earth's magnetic field lines and slam into the upper atmosphere, making it glow like a neon tube. Normally those particles get funneled near the poles. That's why auroras live up north and down south. The field is the funnel, the poles are the exits. So when an aurora appears far from the poles, you usually blame a big storm. The shield gets compressed, the funnel widens, and the glow spills into lower latitudes. Except these nights weren't big. The sun wasn't throwing a tantrum, no classic warning, no obvious storm front. Just calm space weather and a sky doing the wrong thing. And the arcs weren't spill. They were too clean. Thin, curved, almost geometrically perfect. Like someone traced them with a compass and then turned the ink into light. That's when the team stopped calling it an aurora problem and started calling it a geometry problem. Because geometry is what you get when patterns repeat. They overlaid the sightings, not on a map of countries, but on a map of magnetic coordinates. The same coordinate system satellites use when they talk to the field. The arcs snapped into place. They weren't random. They were sitting on the same magnetic lane, like Earth kept sliding through a fixed seam in the invisible fabric. And if Earth is sliding through a seam, the next question is brutal. What is the seam connected to, and why did it start showing itself right when 3i Atlas arrived? Because the timing was too tight to ignore. Every window, the seam lit. Every window, cameras in different corners of the world saw the same kind of arc. A few minutes long, sharp edge, then gone. Like a door opening and closing in the sky, and the door wasn't near the poles anymore. It was wherever the seam crossed. The official comfort story would be rare conditions, a special mix of solar wind density and field direction that just happened to line up a few nights in a row. But rare conditions don't repeat like a metronome. Rare conditions don't show the same geometry from different longitudes. Rare conditions don't shut off like a timer. So they ran the next test the only way you can. Predict the window from 3i/Atlas's pulse cycle, then watch the seam before anyone posts a clip. The seam lit again, right on schedule, and this time the arc wasn't alone. A second, fainter arc appeared a few degrees away, like a parallel lane waking up beside it. That's when you realize you're not watching an aurora. You're watching a pattern in the field itself, something that can paint light wherever it wants if the channel is open. What makes it worse is how normal the report sounded. A pilot says the horizon turned green over the ocean. A farmer says the sky flickered purple over flat land with no storms. Those are the places auroras don't visit. Not because the sky can't glow there, but because the field lines don't usually deliver particles there. Yet the glow showed up anyway. When analysts replayed the all-sky footage, they noticed the arc didn't drift with wind patterns. It rotated with magnetic local time, like it was attached to the field, not the air. And the reverse part wasn't just location. The curtain moved the wrong way, like the flow was coming in from the edge and sliding inward, instead of pouring down from above. That's a small detail, but it matters, because motion tells you direction. Direction tells you where energy is coming from, and this direction didn't point to the sun. So they pulled the upstream plasma data and found something that should have been impossible on a calm night. A thin, repeating pulse and particle pressure, like footsteps. Not a huge stomp, just a consistent tap, 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 arriving on the same cadence as the 3i Atlas window, then fading like nothing had happened. If you want an image, picture Earth's shield as a drum skin. Solar wind hits it, the skin flexes, and the poles glow. Now imagine someone tapping the side of the drum. That's what the maps look like, not global compression. A lateral shove, localized, timed, and precise enough to draw an arc, where the textbook says there's no pin. And once you accept a lateral shove, you have to ask the next question. If something can tap the shield from the side, what else can it steer, and what else can it open? Because the seam didn't just make pretty light, it changed where the radiation lives, it changed where satellites get charged, and it changed which parts of the sky are safe. Stay close, because the next part is where the arcs begin to march across the globe in a sequence, and the sequence matches a path that only makes sense if it's being traced. Here's where it gets worse in the scenario. The arcs don't just appear, they start to move like a sequence, popping up in different places as if someone is drawing a path across Earth. One night it's a clean green bow over the ocean. Next night it's the same bow, but shifted thousands of kilometers. Still the same magnetic local time, still the same sharp cutoff. If it was random space weather, you'd expect chaos. Different shapes, different durations, messy edges. Instead you get consistency. Same thickness, same curve, same timer. So they stop asking why there. They ask why in that order. Because order is a signature. Nature can be violent, but it's rarely tidy on a schedule. They stack the events by time and mark the first bright pixel of each arc. The dots don't scatter. They line up into a track that bends like a hook around the planet. And when you plot that track in magnetic coordinates, it stops looking like a tour of countries. It looks like a single lane being sampled at different longitudes as Earth turns. Meaning the lane might be sitting still in the field, and Earth is simply rotating under it, like a record spinning under a needle that never moves. That would explain the different corners of Earth effect without any magic. The arc isn't traveling across continents. The planet is carrying different places into the same seam. But it still doesn't explain the timer. Rotation gives you location. It doesn't give you a clean on-off window that repeats like a heartbeat. That's where the 3i Atlas pulse window keeps cutting in like a metronome you can't ignore. Every time the window arrives, the seam lights. Every time it ends, it fades. So the teams try the simplest prediction again. They mark the next 3i Atlas window and aim a network of cameras and sensors at the magnetic lane before anything happens. They catch the arc forming from nothing, not growing from the horizon like normal aurora. It ignites in the middle of the sky, like a line drawn in one stroke. It holds steady for minutes, barely drifting, then collapses in a way that looks less like fading and more like switching off. Edge first, center last. That collapse is the part nobody likes because it implies control of boundary conditions. Like the channel closes, not because particles run out, but because access is cut. And access matters more than brightness. Brightness is pretty. Access is physics. Access tells you whether a region of near-Earth space is open or sealed. Now look at the ionosphere, the layer that makes radio bounce and GPS behave. During the arc window, the ionosphere doesn't just get noisy, it becomes striped. Signals that normally arrive smooth start showing tiny ripples, as if they're passing through a comb. A few links drop for seconds, then recover like nothing happened. Pilots report weirdness first because they live on radio, a brief hiss, a brief dead patch, then clear again, right on the same cadence as the sky glow. And the craziest part is how localized it is. Not the whole hemisphere went bad. One corridor goes strange, like a road you can see and avoid if you know it exists. So mission planners start treating the arc lane like weather, but sharper. Not storm, more like beam. A narrow region where the rules are temporarily different. That's when someone notices the lane is not alone anymore. The next cycles show a second lane lighting up in parallel, like the seam is splitting into braided strands. Two arcs, slightly offset, both clean, both timed. One is stronger, one is weaker, and the weaker one sometimes appears first, like a preview of the main event. In this scenario, that's the moment fear shifts from odd aurora to field plumbing, because braided lanes are what you get when currents are being guided. Guided currents don't just paint the sky, they can pump particles into places they don't normally sit, and that changes radiation exposure for anything in low orbit. This is where operators start seeing the quiet damage. A few satellites come back with minor charging events that don't match the space weather forecast. Not catastrophic, just wrong. Enough to trigger extra safing, extra resets, extra weird that engineers hate because it never explains itself in one neat report. And then you get the first truly nasty coincidence. One of these arc windows overlaps a routine orbit adjustment and the thruster burn finishes, but the tracking looks off. Not lost spacecraft. Just a small mismatch in where the orbit solution wants to land, like the measurements are slightly bent while the corridor is open. That's when the lane stops being a light show. It becomes a navigation hazard because if measurements shift inside the corridor, your confidence intervals become a lie. So they do the boring, smart thing. They reprocess the tracking, but they cut out the arc window data. The solution cleans up instantly, meaning something about the corridor is contaminating the measurement environment, not by noise, but by structure, like the signal path itself is being shaped. Once you accept shaped signal paths, you've accepted that space isn't behaving like empty space during those minutes. It has texture, and texture has edges. Edges are where systems break, not always dramatically, but slowly, through repeated stress. A spacecraft that crosses the edge twice a day learns the edge the hard way. Now the obvious question is why this is happening at all. Why would a seam exist, and why would it light up now, and why does it follow 3i Atlas timing? The cleanest explanation inside the scenario is resonance. A repeating pulse is like tapping a glass. Tap it in the right rhythm and the vibration becomes organized. Earth's field is the glass. The solar wind is the background noise. The pulse window is the tap that keeps landing at the same point in the swing. That doesn't require intention. It requires timing. And timing is exactly what the window gives you over and over until the system responds the same way every time. But resonance has a nasty habit. It strengthens the pathway that works. Each cycle makes the seam easier to open, easier to light, and harder for the field to fully relax. That's why the arcs start appearing earlier than expected. The system is preloaded. The door doesn't need a full shove anymore. A lighter touch opens it. And once the door opens early, planners lose their comfort blanket. Because the one thing you can live with is a predictable hazard window. The thing you can't live with is a hazard that starts drifting. A window that creeps earlier by minutes, then by tens of minutes until it overlaps critical operations. In the scenario, the creep is measurable. Not huge, but steady. Like the seam is learning the rhythm and anticipating it, tightening before the trigger fully arrives. Stay with me, because the next part is where the reverse auroras stop being one lane and become a chain of lanes, and that chain begins to wrap around Earth like a belt. And that's exactly what starts happening. The seam doesn't stay a single line. Over a few cycles it multiplies, like one lane becomes a chain, and the chain begins to wrap. You stop seeing an arc over a place. You start seeing a belt of arcs, staggered around the globe, each one lighting when that longitude rotates under the corridor. It looks like the planet is wearing a thin luminous band for a few minutes, then taking it off. Not all at once, but in segments, like a zipper closing and opening. The clips feel unrelated until you line them up by magnetic time, then the segments click together like puzzle pieces, and the belt becomes obvious. That's the first moment you realize the aurora isn't the event. The aurora is the label that tells you where the field is being forced into a new shape. Because when a field gets forced, it doesn't care about borders. It cares about lines, geometry, pressure, and the invisible rails that guide charged particles. So the belt is a symptom. The real thing is the rail. A rail that can grab particles, concentrate them, and pour them into the upper atmosphere wherever the rail touches. Now if this was just a pretty belt, you could shrug, but the belt has edges, and the edges behave like blades. Satellites that cross the belt edge don't just see higher radiation. They see faster charging, sudden sensor noise, tiny resets that look like nothing until you count them. And when you count them, they stack into a pattern that matches the belt timing with uncomfortable precision, like the belt is a schedule the hardware can't ignore. At first, the industry response is quiet. Nobody wants headlines about new space weather, so the language stays sterile. Anomalous charging events, transient disturbances. But the people inside the rooms don't talk like that after midnight. They talk about a corridor that's learning where the traffic is. Because the belt doesn't light evenly. It starts to favor certain altitudes, certain local times, certain orbital planes, like the rail is finding the routes that matter. That's when a second edge shows up, not the outer edge of the belt, the inner edge. Two sharp boundaries with a calmer strip between them. You can fly through a storm and feel random. You can fly through a corridor and feel precise. Two edges makes it feel engineered, even if nobody says the word. And the two edges don't arrive together. Sometimes the outer edge snaps first, then the inner edge follows a minute later, like a lock closing in 2 steps. That 2-step closure is the detail that changes the mood. Because 2 steps means staging. It means the system is not just reacting, it's transitioning. Now here's the ugly part. Once you have 2 edges, you can have traps between them. A spacecraft enters the corridor, gets charged, then the second edge closes behind it, and for a few minutes it's sitting in a pocket where the environment is harsher. Most of the time it's fine. Fine is the most dangerous word in aerospace because fine means you didn't die today. Then one night you get a pocket that holds longer than expected, and a satellite that normally rides through comes out with a clock offset that shouldn't exist. Not ours, not a dramatic failure, just enough offset that a few systems disagree, and that disagreement ripples into networks that assume time is stable. This is where the belt stops being local. When time gets touched, everything gets touched. Because your phone doesn't care about magnetospheres, but it cares about timing. Your maps care, your banks care, your logistics care. All of it sits on synced clocks. So the corridor becomes a quiet risk, not end of the world. More like one bad window at the wrong moment can turn the lights into a question mark. And the windows keep arriving on the same beat, which forces the next conclusion in the story. The beat is not coming from the sun, because the sun is not that punctual. The beat is coming from something moving through the system with a repeat cycle. Something that marks time the way a rotating beacon marks a coast. And that's why 3i Atlas keeps hovering over the narrative like a shadow you can't shake. The windows line up with its rhythm too cleanly to dismiss. Now the belt starts doing something even stranger. It begins to drift in latitude, slowly, like the rail is sliding across Earth's field lines over weeks. That drift makes the belt visit new places. Cities that never see aurora suddenly get a clean arc for 3 minutes, then nothing, then it happens again a week later. People call it beautiful, people call it a miracle. The data people don't call it anything, they just watch the belt walk and they update their wrist maps in silence. Because a corridor that walks is harder than a corridor that stays put. A fixed hazard can be avoided. A walking hazard forces you to chase it, and chasing means you're always one step behind. That's when you start seeing false dawns in the sky. A faint glow appears in the wrong direction, like sunrise on the wrong side, and then it collapses back to black. Those false dawns aren't bright enough to trend. They're bright enough to show up in sensitive cameras, the ones pointed at the sky for reasons nobody posts. And when you stack those camera frames, you see the belt forming before it lights, like a ghost outline that appears a minute early. That's the preloading again. The system is winding up before the window, like tension building in a rope before it snaps tight. In the middle of this, someone tries a simple test. They compare nights with the belt to nights without it, and they look at how fast the belts recover afterward. The recovery gets slower. Each cycle, the field takes longer to return to baseline. Each cycle, the corridor leaves more residue. That residue is subtle, but it changes what normal means in orbit. And when normal shifts, you stop calling it weather, you start calling it climate. Now imagine being the person who has to sign off on a launch in a climate that's changing under your feet, while the public is watching pretty lights and making wishes. You can't point to a storm, you can't point to a flare, you point to a corridor that exists only when the gate opens, and people ask you to prove the gate. So you do the only thing you can. You predict the next belt, you publish nothing, and you watch the skylight exactly when you said it would. The belt light's on schedule. It lights in segments, wraps around the planet like a thin crown, and for the first time it doesn't fade cleanly. One segment stays lit longer than the rest, not by seconds, by minutes. And that's when the corridor stops feeling like a passing rail and starts feeling like a latch. Because a latch can hold, a latch can trap, a latch can change the rules long enough to make accidents look like human error. Stay with me, because the next part is where the latch holds through the end of the window and the belt doesn't disappear. It breaks into two belts, one above the other, like the sky just gained a second seam. The segment that stayed lit didn't fade into nothing. It thinned, snapped, and then it separated, like the glow had layers and the layers stopped agreeing with each other. You could see it with the naked eye in the right places. Two arcs, one higher, one lower, like someone duplicated the same curve and slid it up the sky by a handspan. That shouldn't happen cleanly. Real auroras smear, ripple, crawl. This looked like two rails running parallel, both sharp, both quiet, both holding their shape like wire. The moment the second belt appeared, the instruments did the same thing. Two peaks in particle energy instead of one. Two rises in ionospheric current offset by minutes. If one belt was a door, two belts looked like an airlock. One boundary closes, then a second boundary locks behind it, and suddenly the corridor has depth. Depth means trapped time. It means a spacecraft can enter on a normal pass and find itself inside a pocket that behaves differently until the lock decides to open. And on that night, the lock didn't open on schedule. The window ended on the predicted second, but the belt stayed bright for an extra stretch like the corridor was holding pressure after the trigger had moved on. That's when everyone stopped calling it a window and started calling it a hold. A hold is what you get when a system keeps a state without the push. The calmest explanation is inertia. A big structure takes time to relax, fine, but the hold wasn't a slow relaxation, it was stable, like a hand stayed on the switch. Then the hand let go and the belts didn't fade evenly. One belt dropped first, the other lingered, like the system was choosing which layer to release. In the data, that choice shows up as a clean step, not a slope, a step. And steps are what you get when a threshold is crossed, not when energy simply runs out. So the next question becomes painfully practical. What's the threshold, and how close are we to crossing it more often? Because once you've seen a hold, you can't unsee it. You start looking back through the previous cycles, asking if smaller holds were hiding in the noise. They were. Tiny ones, 30 seconds here, a minute there. The corridor had been practicing. It just took one night to show you what it could do when it commits. That night also delivered the first ground effect people couldn't laugh off. Not the grid collapsed, nothing dramatic, but in a few regions, sensors on long lines saw induced currents that didn't match the usual storm signatures. It wasn't broad, it was narrow like a stripe moving over the map, a stripe that lined up with where the lower belt was brightest. That alignment is what makes engineers go quiet, because if the sky can draw a current stripe on command, you don't need a giant storm to stress systems. You just need a corridor that keeps visiting the same infrastructure again and again. And the corridor did keep visiting. The next cycles returned with the same two-belt structure, and the separation between belts slowly widened. Wider separation means the channel is splitting further, like the field is creating two preferred routes for particles, two lanes that don't mix. Two lanes mean two edges, 4 boundaries total, and every boundary is a place where charging spikes, where signals bend, where normal becomes a guess. The public sees it as beauty, 2 ribbons instead of 1. People post videos and argue about colors as if color is the point. Inside the quiet rooms, color isn't the point. Geometry is the point. Timing is the point. The point is that the belts are behaving like a machine. Now the story adds a new twist that's easy to miss if you don't watch the right plots. The belts begin showing up faintly before the window, not as full glow, but as a thin ghost line, like the corridor is charging up ahead of schedule. That ghost line makes prediction harder because once preloading starts, the start time becomes soft, and soft start times ruin operations. You can work around a hard window. You can't work around a window that creeps. So they try to pin it down by using the one thing that doesn't lie, at least not easily. Relative timing between distant sensors. The relative timing starts changing too. One sensor sees the corridor first, then another, like the channel is sweeping across the magnetosphere in a direction. That sweep has a heading, and the heading stays consistent across cycles, which is when someone connects it to a direction in space that isn't the sun. Not a dramatic point at the culprit moment, more like an uncomfortable overlap. The corridor's sweep direction matches the line the object is moving along. If you're trying to stay calm, you call it coincidence. If you're trying to stay honest, you admit it's a correlation that refuses to go away. And the correlation comes with a new behavior. The two belts begin to hand off brightness. The upper belt brightens, the lower belt dims, then the lower belt brightens, the upper belt dims. Like a pulse traveling between layers, that looks like coupling. Like the system is transferring energy from one channel to another in a controlled way. Coupling is normal in physics, but not like this. Not with a timer, not with clean switches, not with the same cadence every time. Now here's the simple explanation, the one you can say without losing people. Earth's magnetic shield isn't a solid wall, it's more like a stretchy bubble with layers, and sometimes the layers slide and snap when something pushes them. What we're seeing in this scenario is those layers being pushed the same way, repeatedly, until the bubble learns a new motion, and learned motion is what turns a rare event into a repeating feature. Once it's a feature, it starts producing secondary effects that feel disconnected until you line them up. A brief GPS wobble here, a radio dead patch there, a weird sensor reset in low orbit, a faint induced current stripe on a quiet night. None of those alone is a headline. Together, they form a footprint. And the footprint is moving. The next cycles show the belt chain wrapping tighter around Earth, like the corridor is sliding toward an orientation that hugs the planet more closely. That tightening makes the reverse auroras appear in places that are almost absurd, like the sky is ignoring the idea of polar zones altogether. It's not global, it's not everywhere, it's selective. It picks corridors, then it picks them again, as if the field is carving grooves. Grooves are what you get when you run a blade over the same path repeatedly. The path gets easier to cut, and the cut gets deeper. That's why the holds get longer. That's why the ghost lines appear earlier. That's why the belts split and stay split. Now, the thing you're probably wondering is the same thing the teams were asking without saying it out loud. If the corridor can hold after the window ends, what happens when two windows overlap? Because overlap doesn't require two objects. Overlap can happen when the corridor's decay time becomes longer than the gap between cycles. And the decay time was growing. So the scenario's next milestone is not a brighter aurora. It's a night when the belts never fully turn off between windows. They dim, they thin, they almost vanish, then they flare again as the next pulse arrives, like the system is breathing without ever exhaling. That's when the corridor stops being an event you can ride out. It becomes a persistent structure near Earth, a new seam that's present enough of the time that quiet space becomes the exception. Stay with me, because the next part is where that persistent seam begins to lock to the planet itself. And once it locks, it stops drifting across Earth like weather. It starts following the same route again and again, like it's been anchored. The anchoring shows up quietly at first, the way dangerous things always do. The belts stop wandering as much, and the same corridor starts lighting the same places again. Not the same countries, the same path, a narrow ground track that repeats like a stamp, as if the planet has a groove and the sky keeps tracing it. That's when the argument dies, because drift can be blamed on weather. A repeating ground track can't. A repeating ground track is structure. They try the obvious trick, plot every arc by magnetic time, then by geographic time, then subtract Earth's rotation and see what should cancel out. It doesn't cancel, the belt stays in the same place relative to the ground, like it's attached to Earth, not sliding across it. And if it's attached to Earth, you're forced into a question nobody likes. What does a magnetic seem attached to when it stops behaving like a passing ripple? You can say field lines, but field lines move. You can say currents, but currents shift. You can say storm, but storms don't hold the shape. So the people inside the room start using a word that sounds harmless and isn't. Node. A node is where a pattern pins itself. A node is where motion becomes a pivot. Everything else can sway, but the pivot stays, and the rest of the system moves around it. Once the node appears, the belt begins doing something that feels personal. It revisits the same regions like it's checking them. The same ocean corridor, the same inland strip. The same arc over the same horizon, night after night, always on the same timer. That timer still matches the pulse window. The trigger remains external. But the geometry is now internal, like Earth's field has learned a new resting shape. Learned shapes don't disappear fast. Learned shapes harden. They become the new baseline that everything else has to bend around. That's why the next quiet metric changes. The calm night magnetosphere becomes less calm even between windows. It doesn't spike, it doesn't scream, it just holds a small tension like a rubber band kept slightly stretched all the time. And then the windows arrive, and the rubber band snaps tight into the belt, and the reverse auroras draw their clean lines again. The public starts calling them traveling auroras, because that's the closest word they have. But traveling implies movement. This isn't traveling. This is recurrence. It's the same door opening in the same wall. And when you have a door, you start asking what goes through it besides light. The first answer is particles, because particles always go first. The second answer is currents, because currents follow particles like shadows. Then comes the part that makes pilots stop joking. The corridor begins to eat radio in a predictable slice. Not everywhere, not random. A narrow band where comms get thin, then return, like a curtain passing over the signal path. The corridor becomes a schedule you can plan around until it isn't, because anchoring creates a new problem. If the belt is pinned, it hits the same infrastructure again and again. The same undersea cable routes, the same ground stations, the same regional grids. Repetition turns stress into fatigue. Nothing breaks in one night, that's the trap. The story stays calm while the math becomes ugly. Then one night, the node intensifies. The lower belt brightens so hard it throws a pale glow into cloud bottoms, like the sky is lit from above. And the glow holds longer than the window, not by a little. Long enough that schedule becomes a joke. When it finally drops, it drops in segments, like the belt is letting go with fingers, not fading like mist. That segmented release is what forces the next realization. There isn't one seam anymore. There are multiple seams braided around the node. You see it in the sky as stacked arcs. You see it in the data as stacked peaks. You see it in the failures as a cluster of small rungs. Small rungs are the worst kind. They don't trigger panic, they trigger denial. So the teams do what they always do when they need truth. They go after the one measurement that's hardest to fake. They watch the ionosphere like a mirror and track how fast its ripples move when the corridors open. The ripples slow down near the node, like the system is thicker there, like the medium has more grip. Grip is a terrifying word in space physics because space is not supposed to have grip. Grip means something is coupling to something else strongly enough to drag it. And the drag isn't just on particles. The drag shows up as timing slippage across links that cross the corridor. Again, not dramatic. A few microseconds here, a few there. Enough to break the illusion that everything is perfectly synced. Enough to prove the corridor isn't just light. It's a change in how the environment carries signals. Once you accept that, the reverse auroras become the least interesting part. They're just the neon sign on the door. The real issue is what the door is connected to. Because a pin node implies an anchor point in the field, and an anchor point implies a source of stability. Stability in a dynamic system always comes with a cost. It borrows it from somewhere else. In this scenario, that somewhere else starts showing up as a slow distortion in the shape of the magnetosphere itself. The night side tail becomes asymmetrical more often. The boundary bulges where it shouldn't, the recovery time stretches, and every stretch makes the next window start earlier, like the system is anticipating the pulse instead of waiting for it. This is where people start whispering about the corridor, locking in. Locking in means the seam stops needing the trigger as much. The trigger still matters, but the field holds the shape in between. It becomes a standing wave anchored at the node, breathing with the pulse like lungs that learned a new rhythm. Standing waves don't travel, they sit, they hold, they reshape everything around them. That's why the reverse auroras begin appearing with less warning and in broader bands around the anchored track. People in places that never look up at auroras start seeing a faint arc, like a scratch of green glass. It lasts 2 minutes, then it's gone, and the next night it's back. Same arc, same clockwork. You don't need a storm for that. You need a channel that opens the same way every time. And once a channel exists, it gets used. The next surprise isn't in the sky. It's in low orbit, where satellites that never had trouble crossing quiet regions start reporting repeatable charging spikes. The spikes line up with the corridor like footprints in snow. Nobody says it out loud, but everyone reads the same implication. A corridor that's stable becomes a route. Particles route, currents route, effects route. The system starts acting like it has lanes. Now the story turns in the simplest possible way, the way you'd never write if you wanted drama, because reality never uses dramatic turns. A third belt appears, not stacked above the other two, offset sideways like the corridor is widening into a 3-lane structure. And the third belt is dimmer, which makes it more dangerous, because dim belts get ignored. Dim belts still bend signals, dim belts still charge surfaces, dim belts still create edges that eat margins. And margins are what keep boring nights boring. So the teams redraw the wrist maps again, and the maps start looking less like weather and more like a permanent feature you build around. That's when the node does the one thing an anchor is not supposed to do. It shifts. Not far, not fast. A slow migration of the pivot point, like the groove moved under the needle. The belt track follows it, and the reverse auroras begin showing up over a slightly different corridor, which means the seam wasn't anchored to geography. It was anchored to something in the field that just relocated. And if the anchor can relocate, then the system isn't finished. Stay with me, because the next part is where the node's migration lines up with a known weak spot in Earth's field. And once the seam touches a weak spot, the belts don't just brighten. They punch a hole. The weak spot has a name most people never hear, but every satellite operator knows it like a scar. The South Atlantic Anomaly, that patch where Earth's shield runs thin. When the node drifted toward it, the belts didn't just brighten. The edges sharpened, the corridor narrowed, and the glow took on that hard, glassy look again. It started with a simple change in behavior. The corridor stopped opening like a ribbon and began breaking open like a seam under pressure. You could see it in the frames. The arc would form, then split down its own length like a zipper ripping, and the split would spread faster than any normal aurora wave. Inside the corridor, particle counts jumped in a way that wasn't gradual. It was a step up, then another step, like climbing stairs you didn't know were there. The first time it happened, teams assumed a sensor glitch. The second time, they noticed every independent instrument climbed the same stairs at the same seconds. That's when the quiet word hole showed up in chat logs. Not a hole in the atmosphere, a hole in the field's ability to keep certain particles out. Because the corridor stopped behaving like a channel and started behaving like an opening. Not a flood, not a storm, an opening with a boundary you can map. And once you can map an opening, you can predict where it will hurt. Low Earth orbit doesn't have many secrets when you draw the geometry honestly. On the next pass through the anomaly zone, a handful of spacecraft came back with the same kind of soft failure you only see in bad radiation. A camera that restarts, a star tracker that loses lock, a memory bit that flips and gets corrected so fast nobody notices, unless you're counting. The public saw more aurora clips. The operators saw more reboots. The terrifying part was how cleanly both curves rose and fell with the corridor timer. The hole would open, the belts would light, and the reboots would cluster. Then the hole would relax, the belts would dim, and the fleet would breathe again. That's what made it feel like a test, even if nobody said that word. Not a random strike, but a repeatable exposure that kept landing on the same target band. Now here's the part that changes the scale. The anomaly is already a weakness, but it's also a doorway to a bigger reservoir. Above it, trapped radiation belts dip closer to Earth than they do elsewhere. It's why that region is a known hazard for satellites and crewed missions. So when the corridor's node touches that weakness, it isn't just adding stress, it's reaching into a zone that already has stored particles. And stored particles behave differently than incoming particles. They don't need the sun to deliver them, they're already here, waiting in the trap. In the scenario, the corridor begins to milk that trap. The belts brighten, not because space weather got worse, but because the pocket got open. That's why the auroras look reversed. The flow isn't just coming from above, it's coming from the side and in bursts, like a valve pulsing. For a few cycles, the valve stays small. Then one night it opens wider and the corridor stops being a line and becomes a patch. Not a hemisphere-wide storm, a patch with sharp edges, like a stencil laid over Earth, and inside the stencil, the ionosphere behaves like it's under a different rulebook. GPS doesn't fail everywhere, it wobbles inside the patch. Radio doesn't die everywhere, it thins inside the patch. And the patch sits where the node sits. That's when the reverse aurora becomes a map you can't unsee. The sky is literally drawing the footprint of a region where signals get bent. And once a footprint exists, you look for the next footprint, because patterns in nature rarely happen once when a driver is still present. The next nights bring a second patch, offset from the first, like the corridor is creating duplicate openings on a rhythm, 2 doors instead of 1. If you're trying to stay sane, you call it complex coupling. If you're trying to be honest, you admit it looks like the system is learning how to hold shape. That learning shows up in the decay. The patch doesn't disappear smoothly, it snaps smaller, then holds, then snaps smaller again, like a clamp releasing in stages. Stages matter because stages imply thresholds. Thresholds imply control points, and control points are where models start failing. The teams try to model it anyway, because that's what scientists do when the sky misbehaves. They feed the data into magnetosphere codes and wait for sense. The codes can match the brightness, they can't match the geometry. They can match the timing, they can't match the edges. So they adjust the inputs, stronger solar wind, different magnetic orientation, hidden minor storms. The result always looks like weather. But the sky doesn't look like weather anymore. The sky looks like a diagram someone drew and then turned into light. Now you feel the story tightening. Because if the corridor can open holes in weak regions, then the question isn't, is it pretty? The question is how many weak regions Earth has, and whether the node can migrate between them like a finger tapping keys. Earth has more than one scar in its field. There are cusps, boundary layers, places where the shield naturally flexes. If the corridor learns those scars, it doesn't need brute force. It uses leverage. It uses geometry. It uses the planet's own weaknesses. And that's why the next cycle is the one everyone remembers. The node hits the anomaly zone at peak window and the belts don't form as arcs. They close into a thin circle, almost perfect, sitting over the region like a halo pinned to the atmosphere, bright enough to read as a shape through cloud haze. A ring is different from a ribbon. A ribbon tells you flow. A ring tells you containment. Containment means something is being held inside the boundary, not just passing through. It means the corridor isn't just opening the door. It's sealing the door behind whatever arrives, long enough to build pressure, long enough to make the next release feel less like fading and more like a controlled vent. And once you see a ring, you understand why the corridor needed 2 belts, then 3, then a patch. It was building walls. Stay close, because the next part is where the ring begins to rotate without moving on the ground, like a wheel spinning in place. And when a wheel spins in place in the ionosphere, you don't just get lights, you get currents. The ring doesn't drift like weather. It sits over the same region and rotates, slow and steady, like a wheel turning on an invisible axle. You can see it in the way the brightness travels around the circle. The glow doesn't brighten everywhere at once. It runs along the ring in a clean sweep. That sweep has a speed, not a vibe, not a guess, a speed you can measure by frame timing, and the speed stays almost constant across cycles. Constant speed is not how auroras behave. Auroras are chaotic because the driver is chaotic. This driver isn't chaotic, it's repeating. So the ring becomes the new headline inside the rooms, not because it's pretty, but because a rotating ring is a current system you can't ignore. A rotating ring is like an electric motor drawn across the sky. And once you have a motor, you have torque in the field, and torque means the field is doing work. Work means energy is being moved, not just dumped. Energy moved in a loop is what makes induced currents on the ground. That's why the first serious ground signature arrives at the same night the ring rotates cleanly. It's not a blackout. It's not a disaster. It's a set of narrow, synchronized spikes and long-line monitors that shouldn't spike on a quiet, space-weathered day. The spikes are brief, seconds to a minute, but they recur in a rhythm that matches the ring's sweep. If you want a simple picture, imagine a spotlight circling a stadium. Wherever the beam hits, something wakes up, then it moves on. Only here the beam is a current lane in the upper atmosphere, and what wakes up is the quiet electric field that long, yet wires on Earth can't help but feel. It's subtle enough that most people never notice, it's strong enough that engineers start scheduling around it. Because once you see a repeating induced current, you can't pretend it's random anymore. Random doesn't have a phase. The phase is the key. The ring doesn't just rotate, it rotates with a stable phase relative to the 3i Atlas pulse window. Window starts, ring appears, ring begins, sweep, sweep completes, window ends, ring holds a little longer, then releases in steps. It looks like a system with startup, steady state, and shutdown, and that is the most unsettling thing you can say about a sky phenomenon. Now the story gives you a new layer that's easy to miss. The ring has a gap, a missing segment that stays dimmer like a notch, and the notch points in the same direction each time. If the ring was pure Earth physics, the notch would rotate with Earth or with local time. It doesn't. It keeps its orientation in space. That's when the ring stops looking like a purely Earth-tied current and starts looking like Earth is coupling to something external through a fixed direction. The notch becomes a compass needle, except the compass is pointing away from the sun. And if you overlay that direction with the object's trajectory, you get the same ugly coincidence again. The notch points along the line that refuses to leave the narrative. People try to calm it down by calling it a geometry artifact? Fine, but artifacts don't keep the same orientation across different observation setups. So they test the notch the only way you can. They watch from multiple latitudes, multiple longitudes, different camera systems, different filters. Same notch, same heading. At that point, the ring has become more than an aurora. It's a marker for the axis along which the corridor is being driven. And that axis begins to do something you can't handwave. On a few windows, the ring doesn't just rotate, it pulses. The brightness surges in evenly spaced bursts, like a heartbeat layered on top of the sweep. Those bursts show up in magnetometers as matching taps. Tap, tap, tap. Not huge, but identical in spacing. Identical spacing is what makes people go quiet, because identical spacing is how machines talk to themselves. Now, I'm not saying the sky is a machine. I'm saying the sky is behaving like a system being driven by a repeating oscillator. Oscillators exist in nature. Resonance exists, but resonance usually smears. It doesn't draw rings with notches. So the teams chase the physics that can make a notched rotating ring. They find one candidate, field-aligned currents closing through the ionosphere, driven by a standing wave in the magnetosphere. That's a mouthful, so here's the simple translation. Earth's magnetic bubble can ring like a bell. If something taps it at the right rhythm, you can get a stable vibration pattern. Stable vibration patterns can set up current loops. Current loops can create auroras, but more importantly, they can create rotating features. So far, that's normal physics. What isn't normal is that the bell seems to be tapped from the side, on schedule, and the tap rhythm matches a moving object's pulse windows. That's the correlation that keeps tightening the noose. The ring becomes the cleanest indicator of tap strength. When the tap is mild, you get a ribbon. When the tap is strong, you get a belt. When the tap hits the weak spot, you get a ring. And when the ring appears, satellite charging and signal bending get worse inside the footprint. Now the corridor is not just a curiosity, it's a hazard band you can forecast like an eclipse. Forecastable hazards change behavior. Operators start delaying burns, they start postponing sensitive maneuvers, they start rerouting links, and every delay is a quiet admission that the corridor is real enough to respect. Then comes the night the corridor disrespects the schedule. The ring appears early, not by seconds, by minutes. That early start matters because it breaks the model that 3i Atlas window triggers everything. It suggests the system can self-start once it's loaded. Loaded systems are dangerous because they don't need the original trigger. They become their own trigger. The ring starts early, rotates faster than usual, and the knot sharpens until it looks like a cut. At the same time, the belts outside the ring brighten into a faint oval, like the ring has a shield around it. That oval is the first sign of a larger structure, like a bubble within the bubble. And once you see a bubble within the bubble, you understand the next logical move. The corridor isn't only interacting with Earth's field at the top, it's starting to reshape the boundary where Earth's field meets space. The boundary is the magnetopause, the skin of the bubble. If the corridor can pinch the skin, it can change how the entire system breathes. Stay with me, because the next part is where the magnetopause begins to dimple, in sync with the ring. And when the bubble skin dimples on a timer, the sky isn't just glowing, it's being squeezed.